Alright, it's been a bit, but we're back. We're gonna have to do a lot of stuff in this tutorial that's sort of jumping ahead, but it's for the better because we need something to print out hex values, right? We need to see what we're doing. And I just want to let you know that if you're new to assembly, it's kind of painful to make a hex print, which, with hex print, you'll be taking the values inside of registers or memory and printing them out on the screen, converting them to Ascii strings. First, I'm going to clean up this halt. I'm just going to put jump $, which the $sign is like the current instruction in NASM, so it'll just keep jumping. And so that'll be our halt. Now, after this jump and above this times 510, we're going to start our hprint function, our hprint procedure. I'm going to kind of follow C calling convention, C decl, C declare. So right, I'm going to jump into this. I might explain some of it, but we're just going to have to make this and explain it later so that we can get stuff on the screen. So there's our hprint proc, and there's our push BP, mov BPSP, setting up the stack frame for the function. We'll get into that at some point. I'm going to mov bx4 and then do a dot loop colon compare bx0 and jump z dot end. This is sort of like a for loop. bx4, that'll be the amount of bytes that we're going to read. Actually, the amount of nibbles that we're going to read. Sorry. Basically, hprint will print a word of hex, so it'll print the words of registers and all that kind of stuff. So that is number of nibbles. If you don't know what a nibble is, it's half a byte, 4 bits. This is setting up stack frame. All right, and we're going to put this up at the beginning. This is what I like to do, at least. +4 is going to be our hex value. That is our argument whenever we call the procedure. I will get into that in just a second. That's just how I like to document it with comments. Okay, so we're going to put our dot end there, and inside of this dot end, this loop. All right, so we're going to put dec bx, mov ax4, mov cx3, then we sub cx bx. And what this does is it gets the position of the nibble that we want to print. And then we're going to do mol cx, then we'll mov cx ax, then we'll mov ax word, the base pointer +4, right? That is our argument on the stack. That is our hex value argument that we are going to be pushing onto the stack whenever we call the procedure. And then we do some bit shifting, shift AXCL, and then shift right AX12. Basically what this is doing, it's clearing AX so that we have our 4 nibbles left over that we want to print. And doing it like this sort of makes it scalable, and it'll just do the amount of nibbles that we put in BX. Alright, so now we're going to convert it to ASCII. So we're going to compare AL10. This is checking whether it's a number, it's a decimal ASCII, or if it's a alphabetical ASCII. Because with ASCII tables, 0 through 9 and A through F are at different positions in the ASCII table. I'll just pull one up here like that. You got 0 at 48, 9 at 57, and then you have A at 65 and F at 70. And it's actually pretty easy. You just do math on the nibble that you're testing. and just do the offsets in the ASCII table. I mean, it's pretty smart in my opinion. That's just how I've been doing it. So this is comparing whether it's a number or not. If it's not a number, we're going to mov 55 into AH. That's the ASCII value for A, I think. I don't remember. And if it's a num, we're going to mov AH 48, which is another ASCII character. I should probably put those in like char notation, but I don't know, it made a lot more sense doing offsets like that. So whenever we actually get around to generating the ASCII character, we just add AH to AL, and then we'll mov AH 0x03. Here we go. Then we have int 0x10. That's printing each char, and we will jump to loop. We already decremented BX, so that's already handled next time we jump back up to the loop. And that should be the end of that procedure. We're just going to clean up some stuff now for the stack frame. I'm going to pop BP and return. Actually, we're going to return 2. That 2 is adding to the stack pointer after we return, because we have an argument pushed onto the stack whenever we call the procedure. Right, so kinda, if you're new to this, this is kind of a holy what's going on, So I am just going to test this out. I will mov AX 01337. I will push AX. I will call hprint. Now, because we have that ret2, if I just put ret, I would have to say add sp2 after hprint, but Intel is a god, so they have a ret2 to clean up that stack pointer. I'm going to put a jump.char after this mov AH55. I forgot to put that in. If you don't put that in, you won't be able to print your alphabetical ASCII correctly. So yeah. Alright, apologies for that Discord notification. We're going to go ahead and test out hprint. I'm going to mov, delete that. I'm going to mov AX 0x1337, call hprint, and make sure to save it, run our assembly. Nope, and I forgot to push AX. So mov AX 0x1337, push AX onto the stack, and then call hprint. Now we're going to run it. What? I didn't save it. I didn't save the file. Okay. Insert laugh track. So yeah, there's our E and then 1337, and we can test if it's printing the alphabetical ones correctly too. I'll just like move dead into AX and see if it'll print that too. And there it is. There's 1337 dead. Right, so you can kind of turn this into a little hex dump. If you call a bunch of H prints and like push all your registers and all that kind of stuff, like push SI and push DI, just keep calling H print back to back. You can do a little reg dump whenever need to do it. Obviously, there's 0 right now, but maybe if you wanted to push all your segments and all that kind of stuff, which they should be 0 still, yeah, all that's going to be 0. Another little thing I like to do is this new line right here. I just call it NL. It's mov AX0E0A, which is same thing as mov AH0E and then mov AL0A. Int X10, and I'm actually going to add in another one and change that A to a D. So if you recognize this, that is the line feed and the carriage return. So that whenever we call, if we call NL, it'll just put in a little return for us. And you can see the pointer, the cursor is, below E now. So, you can use that between your H prints and all that kind of stuff. I believe that's it for this video. Obviously, we're going to go into compares and mall and what is going on with the stack in the next videos. but it'll be a lot easier to understand it now because we are able to put hex values that are in the registers onto the screen. Thank you. I'll see you next time.